Okay, so let's start. So topic 5.1, fundamental of wave. So wave is something that is new. Although in previously in Form 2, you got learn a little bit like sound wave and so on like that. You got learn a little bit about light, like refraction of light. You got learn about reflection in lower form science. But here we will go in detail. Okay, we'll go in detail what is wave and so on. So what is wave? Okay. Like what I say, please you need to go and watch the recording, because this topic 5.1 is a very important topic. This is the basic that you are going to use in many topics. Okay, not only in Form 4 but also in Form 5. Also got topic that need knowledge from this topic. Okay, so you need to go and watch so that you understand. But for here, now I will only cover a little bit that is important so that we can go to 5.3, okay, like that. Okay, so first thing we need to understand what is wave. Okay, what is a wave? So a wave can be described as a disturbance that travels through a medium from one location to another location. So for example, water. Okay, for example, water. So water is the medium. Okay, so this at first the water molecule is all at this position. All the water molecule is at this position. So this starting position, original position, this is what we call the equilibrium position. Okay, equilibrium position. Okay, this is the starting point. No wave, no wave. Okay, so let's say there's a stone. This stone fall down. So when this stone fall down, what it's going to do is it will push this water molecule go down. Right? So this water molecule, after it go down, it will be at the nearer and it will be at a lower position than the other molecule at the side. Right? So what happened? This molecule at the side will also go down. Also, this one will also go down. And then after this go down, this water molecule go down, it will go back up. Okay, it will go back up. So when it go back up, is it going to stop at the equilibrium position? No, it's not going to stop. It will continue to go up. Okay, going to go up until over the equilibrium position. Okay, until over the equilibrium position. Okay, so this result in all the following molecule will all follow suit. Okay, it will all follow together. So in the end, we will have one molecule start to oscillate and followed by the next and the next and the next and the next. So all the molecules will start to go up and down, up and down, up and down. So this produce the shape of a wave on the surface of the water, where, for example, this water molecule here, this water molecule go up here, this water molecule go up here, this water molecule here, this water molecule here, this water molecule here, here. Okay, this water molecule here, and so on. So it produces the shape like a wave. Okay, so this water molecule can go up and down. It means what? It means the water molecule have energy. Right? Just now at the beginning it's not moving. So it doesn't have kinetic energy. But after the stone drop, the kinetic energy from the stone transfer to the water molecule. So now the water molecule have kinetic energy. And that kinetic energy can transfer from one molecule to another, to another, to another, to another, to another. Okay? So the energy can be transferred. Okay? Can be transferred, but can be transferred through the wave, carry the energy and transfer the energy. But do the water molecule go together with the wave or not? No, the water molecule is still here. This water molecule is still here. This water molecule is still here. This water molecule is still here in this position. Only go up and down, up and down, up and down only. But the energy transfer in a direction that is perpendicular. to the direction of the oscillation. This is direction of oscillation, up and down. This is the direction of the propagation. Direction of propagation. Propagation or propagate is a word that we use to describe the wave move. Usually we don't say the wave move, we say that the wave propagate. Okay? We say that the wave propagate. Alright, so you see the energy can propagate, can be transferred, but there is no transfer of matter. And when there is wave, the energy move. At first, the water molecule is not moving, after that it becomes moving. So that means it disturbs the medium. That is why the definition for the wave is, wave can be described as disturbance. Just now the water, when no wave, the water molecule just stay there. When got wave, it disturbs the medium, right? It disturbs the medium, make the medium start to move. So it's a disturbance that travels through the medium. So if water wave, the medium is water. If sound, for example, right now, sound wave, the medium is air. But sound can also travel in, can also propagate in water, can also, that means in liquid, sound also can propagate in liquid, also can propagate in solid. So that means for sound wave, gas can be the medium, liquid can be the medium, and solid also can be the medium for sound wave. And except light, light do not need a medium. Light is also a wave, but light doesn't need a medium. Okay, do not need a medium. But when the light travel through different substance, travel through air, travel through the water, travel through glass, we say that the air, the water, the glass is the medium. We say like that. But actually, light do not need a medium to propagate. Okay, no need medium to propagate. Okay, so one more time, wave can be described as a disturbance that travels through a medium from one location to another location. Wave can be produced by an oscillation or vibrating system. So you see, wave is always produced by things that oscillate and vibrate. Okay, for example, this water molecule go up and down, produce wave. Sound wave produced by vibration. For example, when you talk, you feel your throat, you can feel that your throat is vibrating. Right? The speaker that produces the music vibrate. So it produces sound. So from vibration. Okay. So what is oscillation and vibration? Oscillation and vibration are repetitive motion about an equilibrium position in a closed path. So oscillation and vibration are repetitive motion. That means it's motion that always repeats itself. For example, the water molecule. You see the water molecule? Okay, you see the water molecule? At first it's here, go down, go back up, go back to equilibrium position. Continue, down, up, equilibrium position. Down, up, equilibrium position. Down, up, equilibrium position. So, you see it is a repetitive motion. So all oscillation, all vibration are repetitive motion. And repetitive motion, we also call it periodic motion. Okay, we also call it periodic motion. Why is it that we call it periodic motion? Because the motion repeats itself in a particular period of time. For example, every 1 second it will repeat itself. Every 1 second repeat itself. Okay, for example, this pendulum. So this pendulum is, what the pendulum is doing is, the pendulum is oscillating. Why is it that we say that the pendulum is oscillating? Because the motion keep on repeating, right? And we also call this a periodic motion because the time it takes to go from here to here and back to here is always the same. Here, go to here, back to here is the same amount of time. Always. If it's 1 second, then it's 1 second. 1 second. 1 second. 1 second. Like that. Always same amount of time. So we call it periodic motion. Okay? Okay. So propagation of wave transfer energy from one place to another without transferring the matter of the medium. Okay, so I want to let you at least see a bit of this activity lah. Okay, try this activity. So okay, every group take one. Okay, every group take one. One, two, three, four, five. So every group, one only. So you join with them lah. Okay. You also one. You join whichever group you like. Okay. Okay. So what is it that you need to do? What is it that I need you to do here? Is you do like what is described inside here. First you pull, and then one person knot is fixed. This end, one end is fixed, another end you move like this. Not up and down, but left right like this. For example like this. Okay. Okay, yeah. You see the wave go and back, that is what we call reflected. The wave reflect. Okay, the wave reflect. Move larger, reflection. Okay. Okay, this is one way. This is one way of moving to produce a wave. Okay, left and right. Another way is you compress. That means though this don't let go like that, this let go, don't let go like that, because there's a chance that you will get a tangle. And when you get a tangle, you need to buy a new one and replace it. Okay? So there are two ways to do it. One way is okay, another is so this is also a wave. This is two types of wave. This is what we call transverse wave. This is a longitudinal wave. Okay. Very good. Okay. So I want to take this time to show you that the type of wave. Okay, so this is transverse wave. Transverse wave is when the oscillation is 90 degrees to every direction. This is longitudinal wave. direction of communication is parallel with the direction of communication. So what happens here is that the waveform is and one more thing, from this activity, you can see that, please don't let go like that. Okay. Another thing that I need you to observe is that there is transfer of energy. Please don't let go like that. Please don't just let go like that. There is transfer of energy, but no transfer of matter. You see the spring is still in your hand, right or not? Okay, you can see the wave, the energy transfer, but the particle, the spring itself doesn't move. Only the energy moves, but the particle itself doesn't move. Okay. Okay. Next, okay, look at this. Okay, we want to look at type of wave, Just now what we learned, what is it that we want to learn is what is a wave, how is it that we can produce a wave, okay? Now we want to look at type of wave. Before we start with how is it that we can group the wave, we have to look at what is wave profile. So wave profile is the side view of the wave used to show wave features such as crest, trunk, wave height, and wavelength. So basically the wave profile is the shape of the wave. For example, this shape, up, down, this shape is what we call the wave profile. This wave profile is important because from the wave profile we can see the feature of the wave. What is feature of the wave? Feature of the wave is the characteristic of the wave that we can use to describe the wave. For example, how is it that you want to describe your friend? You use the feature of your friend. What does it mean by feature? His height, his weight, body size, shape of the face, shape of the eye, color of hair, okay, the distance between the eye, color of skin, and so on, right now, to describe somebody. So all of that are feature of a person: height, weight, shape, color, feature of a person. So wave also the same thing. How are you going to describe a wave? You need to describe using the feature lah. Okay, so how is it that we can see? Where is it that we can get the feature of the wave or the characteristic of the wave? From the wave profile, from the shape. From this shape lah, the shape of the wave, we can get the wave profile. Okay, now, okay, so that is wave profile. Okay, that is wave profile. So for example, here you look at here. Okay, this is wave profile. This part, this is the wave profile. You see here, over here, there is no wave profile. Here got wave profile, and then you can see the wave profile moving forward. You see or not? So the wave where the wave profile can move forward, this type of wave is called progressive wave. Okay, progressive wave or traveling wave lah, wave that can move. Okay, this is what we call wave profile. So what you did just now, you can see the wave profile move, right? What you produced just now, they are all progressive wave or traveling wave. Understand? Okay, now the next one is we want to see as is a stationary wave. So there are two types of wave lah. That means all of the wave can be grouped into two groups: progressive wave, stationary wave. Stationary wave is where the profile of the wave does not propagate with time. For example, guitar. When you strum the guitar string oscillate up and down like this, right? No? But when you strum the guitar string, you don't see the guitar string like this, right? No? The guitar string just like this, right? Okay, this is what the guitar string do. The guitar string does not do like this. So that means in the guitar string, the wave profile doesn't travel. So the wave that is that you have in the guitar string is what we call a stationary wave. Okay, so let's make a stationary wave. Right? Okay, with this. Okay, I need one volunteer. One person. Okay, so I start with lower frequency. That means I oscillate slower. Okay, if I want to produce progressive wave, I do like this and then you see progressive wave. Okay, this is progressive wave. Okay, progressive wave. You want to take off your finger. Okay, you sure? Okay. You go on like how I go, okay? I really believe that the window will be very good. Okay, because it's okay, so this is progressive wave. Okay, now let's make a stationary wave. Okay, this is a stationary wave. See, only go up and down. Okay, stationary wave. Okay, stationary wave. If I see the oscillation is not very fast. If I oscillate faster, what will happen? See this? And is the wave profile moving or not? Not moving, right? The wave profile doesn't move. See the wave profile only go up and down. It's only go up and down. See, there's a fixed point at the center here. See, there's a fixed point. And this one is only go up and down, up and down, up and down. So this is a stationary wave also. Okay, this is also a stationary wave. Okay, but faster. Okay, faster. See, if it's faster, then you can see one complete wave down. If I make it faster, adjust okay, see? Stationary wave is that only go up and down, it doesn't move. Okay, the wave profile doesn't move. That's the correct. Let's see that. Frequency is 1 second. Okay. Good exercise. Okay, so you get the idea what is stationary wave. I do with wave. Okay, because I really worry that you can entangle. If you accidentally let go, the sinking spring will. There's a high chance that the sinking spring will get entangled. If it get entangled, then the sinking string will be broken up. Okay, the sinking string will be broken. Okay, cannot use anymore. There is no way to fix. Once the sinking string is overstressed or entangled, there's no way to fix it. Okay, you have to throw the whole thing away. Okay, cannot use anymore. Alright, so you get the idea of progressive wave and stationary wave. Okay, and then, okay, progressive wave can propagate through medium as transverse wave and longitudinal wave. That means like this. wave can group into two. Progressive and stationary. And then progressive wave can group into two. Transverse and longitudinal. Okay, transverse wave and longitudinal wave. And then the wave also can be grouped into, all the wave also can be grouped into mechanical wave and electromagnetic wave. Okay, mechanical wave and electromagnetic wave. Okay, so this one, I don't want to spend time to talk about it. You later you watch in the recording lah. Okay, you watch in the recording. I want to go to the characteristic of wave. Okay, this part is very important. Characteristic of wave. Okay, so just now I say that if you want to describe somebody, you use the feature, you use the characteristic, right? Not how high, how tall, skin color, shape of the face, color of eye, color of skin, hair color, how the length of the hair, and so on, right? Okay, feature of a person, characteristic of a person. So wave also have characteristic. We use the characteristic of wave to describe the wave. Okay, to describe the wave. So there are 5 characteristics. Okay, wave we can describe the wave using 5 characteristics. The first is amplitude. What is amplitude? Amplitude is the maximum displacement of a particle from equilibrium position. So for example, this one. Let's say this is water wave, water molecule. Let's say this is water molecule. So at first the water molecule is at the center here, equilibrium position. And then when got wave, the water molecule displaces. Remember what is displace? Displacement. It moves away from the original position, move until here. From here, move up until here, maximum. This is the maximum displacement. It doesn't go any higher. So this maximum displacement is what we call the amplitude of the wave. Okay, it's the amplitude of the wave. So if the water molecule go down here until maximum, here to here is also the amplitude of the wave. And usually these two amplitude will be the same lah. Okay, usually will be the same. That means if this water molecule go up 10 centimeter, here it will also go down 10 centimeter also. Okay, usually we take it like that lah, same. Okay. So what is it that can affect the amplitude? Amount of energy. Okay, it's very logical, right? What is it that can make this water molecule go higher? If it can go higher, that means it will have bigger amplitude. Bigger amplitude, how is it that it can go so high? Because it has more energy. So for example, if water wave, if the amplitude is, if more energy, amplitude higher, means that you have a bigger water wave. Okay, you have a bigger water wave. For sound wave, if the amplitude of the sound wave is high, then that means you have a louder sound. Okay, the sound will be louder. Okay, understand? The sound will be louder. For light, if the amplitude of the light wave is higher, that means the light will be brighter. Very bright. Okay, so higher amplitude, more energy. Get the idea? Okay, get the idea? Okay, so that is amplitude. Next is period. What is period? Period is time taken by particle to make one complete oscillation. Okay, or by a source to produce one complete cycle of wave. Basically, period is one complete oscillation, up, down, back to original position, take how much time? Understand? How many seconds? 1 second, If 1 second, up, down, back here, 1 second, that means the period is 1 second lah. Okay, if up, down, back here is 2 seconds, then the period is 2 seconds. Okay, next is frequency. Relax, relax. Okay, frequency. Okay, what is frequency? Frequency is number of complete oscillation made by a particle or number of cycle of wave produced by a source in 1 second. The short one is, what is frequency? Frequency is number of complete oscillation in 1 second. That means frequency is the opposite of period. Period, just now we say 1 complete oscillation take how much time? Frequency is 1 second. How many complete oscillation? If 1 second have 1 complete oscillation, frequency is 1 per second or 1 hertz. If 1 second, 1, 2, then that means the frequency is 2 hertz. Okay, understand? So period and frequency is a reciprocal of each other. That means if period, okay, that means period will be equal to 1 over frequency, and frequency will be 1 over period. Okay, reciprocal to each other. So that means if you know period, you can calculate frequency. You know frequency, you can calculate period. Okay? Any question? Okay, if no question, then we have to stop here today. Okay, I don't want you to miss your bus or anything.